You're sitting around a fire, dark pressing in from every side, smoke cutting through cold air. Someone across the flames makes a sound. Not a word. Not quite. Something between a grunt and a call. Sharp at the start, long at the end. You don't know what it means, but you understand it anyway. Your body responds before your brain does. Danger. Move. Now. That sound is older than language, older than tools. It came from something that looked almost like you, but wasn't. Something that lived and died and left almost nothing behind except bones and a question no one has fully answered. What did they actually sound like? Not what did they say. What did they sound like? The raw physical sound of the first human voices rising out of the dark. Here's what most people don't realize. Sound doesn't fossilize. The voice is muscle and air and cartilage. It leaves no trace in rock, no impression, no outline, no residue. What we have instead are bones. Specifically one bone, the hyoid, a small U-shaped structure sitting at the base of the throat. It's the only bone in the human body that doesn't connect directly to any other bone. It just floats there, anchored by muscle, and it controls almost everything involved in complex speech. The shape of that bone, its thickness, its angle, tells researchers whether a creature could modulate sound the way modern humans do. It's not proof, it's a fingerprint. And for most of human prehistory, that fingerprint was missing entirely from the fossil record. The oldest hyoid bone ever recovered from a human ancestor came from Kebara Cave in Israel, 60,000 years old, a Neanderthal. When researchers compared it to a modern human hyoid, they found something unexpected. The two bones were nearly identical. Same shape, same proportions, same mechanical range of motion. That single small bone rewrote the conversation about Neanderthal communication. For decades, the assumption was that Neanderthals were grunters, limited, primitive. The hyoid said something else entirely. It said their throats were capable of producing the same range of sounds ours are. Whether they used that capability for true language is still debated. But the hardware was there. The instrument existed. What they played on it remains unknown. Go further back. Homo Heidelbergensis, 500,000 years ago. Ancestor to both modern humans and Neanderthals. Researchers recovered several hyoid bones from sites in Spain, preserved in a limestone pit called the Cima de los Huesos, the pit of bones. Dozens of individuals thrown in or placed there by others. The hyoids matched the Neanderthal pattern closely. Broad, sturdy, positioned low in the throat. That low larynx position is critical. In most animals, the larynx sits high in the throat. Dogs, cats, chimps. High larynx means better protection against choking, but severe limits on vowel production. The low larynx in humans creates a longer vocal tract, more space, more resonance, more range of sound. It comes at a cost. We can choke on food in a way no other primate can. Evolution created safety for speech. But Heidelbergensis wasn't the beginning. Push back further. Homo erectus. 1.8 million years ago, no hyoid bones recovered. Almost nothing from the throat region survives. What researchers use instead are the inner ear canals. The semicircular canals help with balance, but the cochlea, the spiral chamber deeper inside, is tuned to specific frequencies. Modern human cochleae are calibrated to the frequency range of human speech, exactly the sounds we make when talking. Erectus cochleae, reconstructed from fossilized skulls, show early tuning in that direction. Not identical to ours, but trending toward it. The ears were beginning to specialize for a kind of sound that didn't fully exist yet. Here's what that means. The ear evolved to hear language before language existed. The receiver developed before the signal was fully formed. That's not an accident. That's a feedback loop. Groups that could produce and detect more nuanced sounds survived better. They coordinated hunts more precisely. They warned each other faster. They passed information that kept the whole group alive. Every small improvement in vocal range created pressure to develop better hearing. Better hearing created pressure for more precise vocalization. Back and forth, generation by generation, for hundreds of thousands of years. The voice and the ear pulled each other forward together. Neanderthals are where it gets complicated. The hyoid matched ours. The inner ear anatomy was close. Brain endocasts, impressions of brain tissue left inside fossilized skulls, show development in Broca's area, the region in modern humans most directly associated with speech production. Neanderthals had it. They made pigments and wore shells. Evidence of symbolic thought. They buried their dead. Some evidence suggests they cared for individuals too injured to care for themselves. A population in Iraq called Shanidar. One individual survived for years with a crushed arm, a damaged eye socket, severe arthritis, kept alive by others. Complex social behavior requires complex communication. It doesn't require words, but it suggests something more than grunting. Researchers at the University of New England ran acoustic modeling in 2021. They built a computer simulation of the Neanderthal vocal tract using skeletal measurements, skull dimensions, palate shape, estimated tongue position, hyoid placement. Then they ran it. The modeled voice was lower than a modern human male, slightly flatter, less variation in the higher frequency ranges, but it produced vowels, distinct vowels, separable sounds that a listener could tell apart. It wasn't the same voice as yours, But it wasn't noise either. It was something in between, something recognizable and alien at the same time. Further back still, Australopithecus, 3 million years ago. Lucy and her kind. The hyoid from these creatures looks like a chimpanzee's, wide and boomerang-shaped, high larynx, limited vowel space. They almost certainly couldn't produce the range of sounds even early Homo could manage. What they had was likely closer to what great apes produce today. Calls, not words. Fixed signals attached to fixed meanings. Alarm calls, contact calls, social displays. Chimps have distinct vocalizations for eagle versus leopard versus snake. Each sound hardwired, not learned, not varied. A chimp cannot change what it says even if it wants to. The call belongs to the situation, not to the choice. That gap between chimps and even early Homo erectus is enormous. It's not a smooth slope. Something changed. The anatomy shifted relatively quickly in evolutionary terms. The larynx dropped, the tongue became more mobile, the hyoid thinned and changed shape. Researchers think language didn't evolve once. It evolved in layers. Gesture first, probably. Reading intention from body movement. Then prosody, the rhythm and melody of sound carrying emotional content before it carried meaning. Then referential calls. Sounds tied to objects. Then syntax. Rules for combining sounds into sequences with meaning larger than any single part. Each layer built on the last. Each layer took tens of thousands of years to stabilize. Most of those layers left no fossils at all. What can actually be reconstructed is narrow. Hard tissue only. Bones and the spaces between them. Researchers use CT scans of fossil skulls to measure the dimensions of the pharynx, the nasal cavity, the oral cavity. Those measurements feed into acoustic models. The models are imperfect. They assume things about soft tissue that can't be verified. Tongue muscle density, lip mobility, breath control. A trained opera singer and an untrained person share identical throat anatomy. They do not sound the same. Anatomy sets the range. Behavior, learning, and culture determine where within that range an individual lands, and culture doesn't fossilize. So what did they sound like? The best current answer is this. By 300,000 years ago, archaic Homo sapiens likely produced sounds in roughly the same frequency range as modern humans, somewhat limited in high-frequency consonants, strong and low-register vowel sounds, voices that carried well across open ground. Not quite the voices you hear today, but voices, actual voices, not growls, not clicks, not animal noise. Something you would recognize immediately as human communication even if you couldn't decode a single syllable. By 100,000 years ago, the anatomy was essentially modern. The sounds were there. By 50,000 years ago, behavioral evidence explodes. Symbolic art, long-distance trade, musical instruments, bone flutes in Slovenia, dating back 60,000 years. People who made instruments understood pitch, resonance, and controlled sound production. Their voices were doing at least as much as the flutes. That's what humans,